Hi everyone, this is Peace. In this question, we have linear programming problem using Simplex Method. We have solved the following linear programming problem using the Simplex Method. The question says minimize z equal to 7x1 minus 10x2 subject to 3x1 plus 2x2 less than or equal to 18, 4x1 plus x2 less than or equal to 16, 2x1 plus 3x2 less than or equal to 21, where x1 and x2 is greater than or equal to 0. To solve this problem, we need to convert the inequality to an equation and also to add our slack variable. For the solution, we have 3x1 plus 2x2 plus x1 equal to 18. For the second constraint, we have 4x1 plus x2 plus x2 equal to 16. For the third constraint, we have 2x1 plus 3x2 plus x3 equal to 21, where x1, x2, x3 is greater than or equal to 0. We have our objective function to be 7x1 minus 10x2. Therefore, we're going to write our slack variable to the objective function. So we have 7x1 minus 10x2 plus 0x1 plus 0x2 plus 0x3. After this, we are going to draw our table. From our table here, we have CJ here, we have BV, we have CB, we have ZJ, we have the solution, we have ratio. The CJ is the coefficient of our objective function. From here, we have the coefficient of the objective function to be 7 minus 10. We have 0, 0, 0. So we're going to add that here. We have 7 here. We have minus 10, 0, 0, and 0. For this row, we have x1, x2, x1, s2, and x3. Now we're going to represent it here. We have x1, x2, x1, x2, and x3. So the next is to write our constraints here. So we have the first, second, and third constraints. So from here we have 3, 2, and 1. Under x1 here we have 3. For x2 we have 2 here. For this we have 1. We don't have x2 and x3. Therefore we are going to represent that with 0. We have 0 and 0. For the second constraint, we have 4, 1, 4, 1. There is no x1, we write 0. For x2 here, we have 1. No x3, we write 0. For the third one, we have 2, 3. We have 2, 3. For x1, 0, x2, 0. x1, 0, x2, 0. For x3, we have 1. The next is to find our basic variable. If you have been following my lectures, the identity matrix form the basic variable here. So here we have 1, 0, 0, 0, 1, 0, 0, 0, 0. So our basic variable here is x1, x2, x3. So we have x1, x2, and x3. The next is to find the value for x1, x2, and x3. So the value for x1 here is 0, for x2 is 0, and for x3 is 0. Therefore, represent them here, 0, 0. The next is to find your solution, which is B. Here we have our B to be 18, 16, and 21. We have 18, 16, and 21. The next is to find our ZJ. To find the ZJ, we have the formula to be CB inverse of B, AJ. Our ZJ will be 0 times 3 will give us 0, 0 times 4, 0, 0 times 2, 0. I will combine the 3, 0 plus 0 plus 0, we have 0. 0 times 2, 0, 0 times 1, 0, 0 times 2, 0. So when we sum everything, we have 0. For here, we have 0 times 1, 0, 0 times this, 0, 0 times 0, 0. When we sum everything here, we have 0. For the next one, we have 0 times 0, 0, 0 times 1, 0, 0 times 0, 0. When we sum everything up, we have 0. For this one, we have 0 times 0, 0, 0 times 0, 0. So when we sum everything, we still have 0. For our zeta here, 0 times 18, 0, 0 times 16, 0, 0 times 21, 0. When we sum everything, we have 0. The next is to find our reduced cost. To find the reduced cost, we have Cj minus Zj. For minimization problem, to find the reduced cost, we either use this formula Cj minus Zj. For us to reach optimality, the numbers must be greater than or equal to 0. If you're using this formula Zj minus Cj, for you to reach your optimal solution, the numbers should be less than or equal to 0. If you're using this formula Cj minus Zj, for you to reach optimality, the number should be greater than 0. So everything tends to positive, which you have 0, 1, 2, 3, 4. If you're using this formula Zj minus Cj less than or equal to 0, for you to reach optimality, the number should be less than or equal to 0. That means everything tends to the negative. We have 0, minus 1, minus 2. But since I'm using this formula, for me to reach optimality, my reduced cost needs to be 0 or positive numbers. Since I'm using this formula to get my reduced cost, which is Cj, we have 7. 7 minus 0, we have 0. For this, we have minus 10, minus 0, we have minus 10. 0 minus 0, we have 0. 0 minus 0, we have 0. 0 minus 0 here, we have 0. So for us to find our key column, we need to select the least value from the reduced cost. So from here, 10 is our least value. And here the key column or the pivot column here is this. So from our pivot column or key column, we get our ratio, which is this solution all over the key column or pivot column. So we have 18 all over 2, which will give us 9. 16 all over 1, which will give us 16. 21 all over 3, which will give us 7. After finding your ratio, so the next is to find your pivot row or your key row. So from here, you select the least value. The least value forms your pivot row or key row. So here 7 is our least value. This is our key row. From here, our pivot element or key element is 3, because this is where the two lines join. Here 3 is our pivot element or key element. From here, we'll get our leaving variable and entering variable. X3 here is our leaving variable, meanwhile x2 here is our entering variable. So that will lead to the second table. For this table, which is our first iteration, we have our Cj here, we have the basic variable. So we have our solution here and we have our ratio. Therefore, we are going to represent these values here, nothing changed. We are going to write these values here into our new table. We have 7 here, we have minus 10, and we have 0, 0, and we have 0. Remember, for the basic variable, we have x1, x2, we have x1, x2, and x3. So for here, x3 is the leaving variable and x2 is the entering variable. Therefore, we have x1, x2, and x2 here. Therefore, here we have x1, x2, and our entry variable, which is x2. Therefore, we get the values for x1 and x2 and x2. The coefficient for x1 is 0, x2 is 0. For x2 here, we have minus 10. We write minus 10 because we have minus 10 here. So the next is to write the values for x2. Remember here, we have our key element or pivot element to be 3. And the pivot element for a new table must be 1. So for it to be 1, we need to divide it by itself, which is 3 all over 3. And the same thing applies to other values here. So we have 2 all over 3, 3 all over 3, which will give us 1, 0 over 3, which will give us 0, 0 over 3, which will give us 0, and we have 1 over 3. So therefore, we're going to write them down here. Remember, we have 2 here. We say 2 all over 3, 2 over 3. For the second one, which is our key elements or pivot elements, we have 3 over 3, which is 1. So other values, we have 0, 0, which we have 0 over 3, which is 0, 0 over 3, which is 0. And the next one is 1, which we have here 1 all over 3. So the next is we're going to find the values here, the missing values here. So for us to find x2 here, we are going to write out these values here. and also write out the values for x2, which is this, to find our new values. So I'm going to show you what I'm saying. So I've written down the values here. For x2 here, we have 2 all over 3. We have 1. From our new table, we have 2 over 3, 1, 0, 0, 1 over 3, and 7. So we have 2 over 3, 1, 0, 0, 1 over 3, and 7. For this x2, remember we have x2 here from our old table, which is 4, 1, 0, 1, 0. Therefore, we have 4, 1, 0, 1, 0. And also we have 16 here. We have 16. Therefore, to find the new value here for x2, because we're looking for value for x2, remember, this is our key element or pivot element. 1 is our key element or pivot element. Therefore, we are going to multiply this key element or pivot element with the opposite sign of the adjacent value. And the adjacent value we have here is 1. So if we are to multiply, we'll multiply times minus 1. The trick here is to get 0 when we combine these two numbers. So minus 1 times 1 will give us minus 1. Minus 1 plus 1 will give us 0. So the same thing applies to other values. We're going to multiply by minus 1. We're going to multiply other values by minus 1 times minus 1. Same with this times minus 1. So when we combine these two numbers, we'll get our new value for x2. So our new value for x2 will be, we have minus 2 all over 3 times minus 1, which will give us minus 2 over 3. So minus 2 over 3 plus 4, that will give us 10 all over 3. We have here 1 times minus 1, which will give us minus 1. Minus 1 plus 1, which will give us 0. For here, we have 0 times minus 1, which will give us 0. 0 plus 0, we have 0. For these, we have 0 times minus 1, which is 0. 0 plus 1, we have 1. For this, we have 1 over 3 times minus 1, which will give us minus 1 over 3. So 0 minus 1 over 3, which will give us minus 1 over 3. For this, 7 times minus 1, which will give us minus 7. Minus 7 plus 16, which will give us 9. We have 9 here. So this is the value for S2, our new table. So we have here 10 over 3 for x1, 0 for x2. So we have 10 over 3 here. The next one we have 0, write 0. We have 0 for the next one. We have 0 here. For x2 here, we have 1. We have 1. For this x3, we have minus 1 over 3. x3, we have minus 1 over 3. For b here, we have 9. Look at, we have 9, so we put 9 here. So the next is to find our x1. So we do the same thing. We are going to write these numbers out and also write the formal x1, which is 32100018. We'll write them out to find our new value for x1, which is going to be here. So I'm going to show you what I mean. So here I've written the numbers out. We have x2 here to be 2 over 3, 1, 0, 0, 1 over 3, 7. From here we have 2, 1, 0, 0, 1 over 3, and 7. For x1, our formal table for x1, we have 3, 2, 1, 0, 0, 18. The same thing here, we have 3, 2, 1, 0, 0, and 18. So with this, we are going to find the new value for x1. So our new value for x1 will be, remember, this is our key element or pivot element. This serves as our focus point. So what we do here is to multiply our key element or pivot element with the opposite sign of the adjacent value. So the adjacent value here we have is 2, which is plus 2. If we are to multiply this, we'll multiply this with times minus 2. The essence of this is so that when we combine these two values, is going to give us 0. When you combine these two, like 1 times minus 2, which will give us minus 2, minus 2 plus 2, that will give us 0. This applies to other values here. So we're going to multiply other values with minus 2. We multiply here times minus 2, times minus 2, times minus 2, times minus 2, times minus 2. So with this, we're going to find our new value. So we say here, 2 all over 3 times minus 2 will give us minus 4 all over 3. minus 4 all over 3 plus 3, which will give us 5 all over 3. For this, we've already calculated this, which is 1 times minus 2, minus 2, minus 2 plus 2, which will give us 0. For here, 0 times minus 2, which is 0, 1 plus 0, which will give us 1. For here, we have 0 times minus 2, which is 0, 0 plus 0, which will give us 0. For this, 1 over 3 times minus 2, which will give us minus 2 all over 3, plus 0, which will give us minus 2 all over 3. Here, 7 times minus 2, which will give us minus 14. 18 minus 14, which will give us 4. So this is the value for x1. We are going to write these values here. So remember, we have 5 all over 3. We have 5 over 3 for x1. For x2 here, we have 0. We put 0. For x1 here, we have 1. We put 1. For x2 here, we have 0, 0. For x3, we have minus 2 all over 3, minus 2 all over 3. For b here, we have 4. That means we'll write 4. The next thing is to find the z. So to find the value for our z, we say 0 times 5 all over 3, 0. 0 times 10 over 3, 0. Minus 10 times 2 all over 3, we have minus 20 all over 3. So when we sum everything up, we have minus 20 all over 3. So for this, we have 0 times 0, 0. 0 times 0, 0 minus 10 times 1, we have minus 10. So when we sum these, we have minus 10. So for this here, we have 0 times 1, 0. 0 times 0, 0 minus 10 times 0, we have 0. So when we sum everything up here, we have 0. For this, we have 0 times 0, 0, 0 times 1, 0, minus 10 times 0 will give us 0. When we sum everything, we have 0. For this column, we have 0 times minus 2, 0, 0 times minus 1 over 3, which will give us 0. Minus 10 times 1 over 3, which will give us minus 10 all over 3. So when we sum everything, we have minus 10 all over 3. We can as well find our zeta here. We have 0 times 4, 0, 0 times 9, 0, minus 10 times 7, we have minus 70. So when we sum everything up here, we have minus 70. The next is to find our radius cos. So to find the radius cos, remember we have Cj minus Zj. So to find our radius cos here, we have Cj minus Zj. So here we have 7 minus 20 all over 3 will give us 41 all over 3. Remember, minus is plus. I said 7 minus 20 all over 3 will give us 41 over 3. Minus 10 minus 10 will give us 0, because minus is plus. So 0 minus 0, we have 0. 0 minus 0, we have 0. 0 minus 10 all over 3 will give us 10 all over 3. Remember, minus is positive. So here we've reached our optimal solution because we don't have any negative value here. So all the values here are 0 and greater than 0. So we've reached our optimal solution. We're going to find our optimal value. So we're going to confirm if we are getting the same answer with this. So here, first of all, we find our S transpose. Our X transpose is all the values here in our solution, in our B. All the values in our B, we have 4, 9, and 7. And for the 4, 9, and 7, we have x1 to be 4, x2 to be 9, and x2 to be 7. So x1 here, we have 0 because there's no value for 0. For x2, we have 7, which is this. For x1, we have 4, which is this. For x2, we have 9, which is this. This is our x2. For x3, there's no value for x3, therefore we put 0. So from our X transpose, we get our optimal solution, which is the zeta. So the next is to substitute this number into our objective function. So from our objective function, we have 7x1 minus 10x2, 0x1 plus 0x2 plus 0x3. So we're going to substitute this value here into here. Therefore, we have 7 times x1. Remember, x1 is 0 minus 10 times x2, which is 7. We have 7 here. So we write 7 plus 0 times, for x1 we have 4. We put 4 here, plus 0 times, for x2 we have 9. So we add 9 here, plus 0 times, for x3 here we have 0. Therefore, we have 0 here. So we are going to sum everything here. 7 times 0, we have 0. 10 times 7, we have minus 70. Plus 0 times this, we have 0. 0 times 9, we have 0. 0 times this, we have 0. So we'll sum everything up. Our optimal solution is minus 70. Observe that we got the same answer with what is here. That means minus 70 is our optimal solution. We've come to the end of this tutorial. If this video interests you, why don't you subscribe, put your comments, and also like the video. And I'll see you in my next lesson. Bye.